We're talking about the complex plane, and let me remind you, the way we visualize complex numbers is by plotting them in the plane. We graph the number z equals a plus bi by plotting the point a comma b. And so that means that this point is a units to the right and b units up from the origin. In the complex plane, this is the real axis and this is the imaginary axis. I want to define a term. The absolute value, or modulus of z, this complex number, is defined as the absolute value of z is the square root of a squared plus b squared. Now, this comes right from the Pythagorean theorem. This quantity is exactly the length of this red segment. It's the distance of z from the origin. And that's exactly what absolute value is for real numbers, the distance from the origin. So for complex numbers, it means the same thing. Sometimes the term modulus is used for absolute value, but it means absolute value of z. Now, in addition to this kind of form for complex numbers, there's another form that's kind of reminiscent of polar coordinates. Now, if we call this length r, and we measure an angle from the real axis, theta, we can actually put z in terms of r and theta in the following way. First of all, let's observe that r is exactly equal to the modulus of z. R equals the square root of a squared plus b squared. And secondly, let's observe that cosine of theta is a over r. So a equals r cosine theta. And sine theta is b over r, so b equals r sine theta. And so we can rewrite this form, which is actually called rectangular form, in another way. Z can be written, since a is r cosine theta, I'll put r cosine theta in place of a, plus b is r sine theta, I put r sine theta times I. Now the convention is to pull the r out and put parentheses, cosine theta plus, and you put the I in front. You don't want it to look like you're taking the sine of theta times I. So I sine theta. This form is called trigonometric form, sometimes called polar form. And it's really useful, as you'll see in a lesson or two. But we'll be using trigonometric form a lot. What we're going to do in the near future is learn how to convert back and forth between trigonometric form and rectangular form.